So it is 7 o'clock. So started the recording. So am I audible? Can anybody confirm? Whether my voice is, are you able to hear my voice? Okay, so I welcome you to the live session for the NPT National Program on Technology Enhanced Learning. So this is a course Engineering Graphics and Design. So currently we are in the week 6. So introducing myself, I am Vikram Balaji, a research scholar from the Department of Mechanical Engineering in IIT Madras. The course instructors, as you might already know, is Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from IIT Delhi. So I welcome you to the week 6 of the live sessions. So in previous sessions, what did we learn? So in previous sessions, we briefly learnt about two main topics. One is the section views, and other is the auxiliary views. So we saw some sample problems related to sectioning of objects. So, and we also learned what is an auxiliary view and why it is important, and how auxiliary view helps us to generate the true shape of inclined surfaces. So this session we are going to see about isometric projection. So before that, we will take a quick recap of the different methods of projections which are available. So we'll just switch on the pointer. So as you can see, the projection methods are defined by the type of the projectors, which may be either parallel or convergent. So this, according to this classification, there are two types of projectors. One is a parallel projector, another is a convergent projector. The second is the orientation of the projectors in relation to the projection plane. Whether the projectors are orthogonal to the projection plane or they are at an angle oblique to the projection plane. The orientation of the object with respect to the projection plane, whether the object is parallel to the or orthogonal to the projection plane, or is it oblique to the projection plane. So based on these three criteria, we can totally classify the type of projection into four main classes. So first is the orthographic projection, second is the axonometric projection, third is the oblique projection, fourth is the central or perspective projection. So orthographic projection is the most widely used projection method in engineering drawings. So in this table you can see, so based on the two type of projectors, so in this picture you can see that there is an observer, there is a projection plane, and there is an object. So and there are the projectors. So the projectors start from the object and they converge towards observer. So in this case, the projectors are convergent in nature. So here we saw infinite and finite. So finite means convergent, infinite means parallel. So within parallel projectors, you can have many cases. So as I said, the other things are there, right? So the orientation of the projectors. So if the projectors are parallel, you get what is called as orthographic, and among that we have two types. So whether the object itself is parallel or orthogonal to the projection plane, or it is oblique. So the difference between the orthographic and axonometric view is that the main features of the object, that is these edges, you can say, they are parallel or orthogonal in case of the orthographic projection, and they are oblique in the place of axonometric projection. So after that, you have something called oblique projection, where the object itself is not parallel or orthogonal. The object is parallel or orthogonal, but the projectors are not perpendicular. So they are at an angle. They are still parallel, but they are at an angle. So if I go to the next picture, you will be able to visualize. So here you can see multi-view is nothing but orthographic projection. So you have the object is parallel to the projection plane, and the projectors are also parallel to each other, and they are perpendicular to the projection plane. So this is an orthographic projection. In axonometric projection, you can see that the object is not parallel to the projection plane. It is oblique to the projection plane, but you can see that the projectors are still parallel to each other and they are perpendicular to the projector plane. So here you can see this is third one is oblique projection. The object is parallel to the projection plane, but the projectors are parallel to each other, but they are inclined to the projection plane. They are not perpendicular. So if I take the pen, so this is some angle. Here in this case you can see it will be 90 degree. The projectors are perpendicular to the projection plane. So here also this will be 90 degree, but this will be not 90. So it is some oblique. So that is the difference between these three types of projection. The last one is called perspective projection. Here the projectors are convergent to the observer. So you can see the projectors are arising from the various points on the object, and they are converging towards the object. So here you can see the summary of the different projections. So the main classification is between parallel and perspective. So parallel, you can see that in all these three cases the projectors are parallel to each other. So that is the one big distinction. Here it is convergent. So convergent means it is a perspective. Among parallel we have orthogonal and oblique, and among orthogonal we have two classifications. One is the orthographic, another is the axonometric. So orthographic, as we have learnt earlier, we have many different types. So main broad two types are the first angle projection and third angle projection. So these two are widely used in engineering drawing. In axonometric projection we have many other classification. The main are isometric, dimetric and trimetric. So in isometric you can see that the all edges are equally inclined to each other. Here two angles are equal and third angle is not equal. And in trimetric all the three angles are different. So that is one thing. In oblique projection we have again many other types. So one is called cabinet, another is cavalier, another is military. And perspective we have based on the number of this thing convergent points. You can say it's a single point, or it's a 2 point or 3 point perspective projection. So this is the recap. So in this session, as I told, we are going to look about isometric projections. Okay. So isometric projection is nothing but, first of all, it's a method to represent the pictorial view of a 3D object on a 2D surface. So you can see that you are able to see the three-dimensional view of the object. So this is a cube, and if you in orthographic projection you can able to see only one face of the cube. That is either it is a front face or it's a top face or side face, like that. But here you can able to see many faces. At least we are able, in this we will be able to see three faces are there. So other three faces are hidden. So we are able to see three faces. So this is one face, this is the second face, and this is the third face. So like that. So one thing in isometric projection is that the main features of the object are oblique with respect to the projection plane, and the projectors are parallel. So projectors, if you see, they are all parallel to each other and they are perpendicular to the projection plane, but the object is not parallel to the projection plane. It is oblique. So you can see that there is this object is not parallel to the projection plane. It is slightly inclined. So it is inclined in such a way that all the three axes are equally inclined with each other at an angle of 120 degree. So in this case you can see this is one axis and this is one axis. The third axis you can either go down or up. So usually we go up. So because if this you consider x and if you consider this y, according to the right hand thumb rule you will get the z is at top. So if you extend this, you can see that this angle is 120 degree, again this angle is also 120 degree, and same this angle is also 120 degree. So all the axes are equally inclined with each other at an angle of 120 degree. But what happens is the features of the solid are not parallel or orthogonal to the projection plane, therefore the length is shortened. So you can able to visualize. So first we have a cube. So in the orthographic projection, let us say that we are looking at one face. So this red color shaded region I am given here for identification. So this is one face. So let us say that I am having this cube over here. So I hope you guys are able to see this cube. So now you will be able to see only one face. So that face, okay, so let us say this is that face. So that face shows the speaker, so in this product. So you are able to see this face. Now gradually what I am doing is I am slightly inclining the object, that is I am turning the object like this horizontally. So now you will be able to see two faces, this face and this face. So you can see that these edges which were this edge which was previously parallel to this plane, now it is inclined. So after this view, next is what I am doing is I am going to slightly incline the cube downward like this. So now you are able to see three faces. One is the zebronics, then this one and this one. So you can see that the axes are this axis, and this axis. So you can able to visualize that they are now equally inclined to each other. So other than this, what I can do is alternatively, instead of rotating downwards, I am rotating upwards. Now instead of top face, you are able to see the bottom face and the two side faces. So this is how the illustration of isometric projection. So first we are seeing a single face, then we are horizontally rotating such that we are able to see two faces, and now we are able to again rotate. So if you see that these edges, all these edges are not parallel to the projection plane, so they are inclined at an angle to the projection plane. Because of this, there is something what we call as foreshortening that we are going to see now. So up to this, any doubt is there? So I just introduced the isometric projection. So I hope there is no doubt. So if there is any doubt, you can ask me. So I just explained how we are able to mentally visualize what is isometric projection. So this is foreshortening. Foreshortening means this. So first of all, the edges parallel to the projection plane show the true length. For example, I am having this pen with me. So if this is the vertical plane with the screen, so I am having this pen. Now this edge is parallel to the projection plane, therefore it shows the true length. Suppose this is 50 mm, you will be able to see the projection is also 50 mm. Suppose if I am inclining this pen like this, and now it is not parallel to the screen, now it is inclined at an angle to the screen, because of which this 50 mm while projecting it will be lesser, so it will be less than 50 mm. So what happen is, as I told in the isometric projection, so this was previously parallel, now it is inclined, and again now this is isometric projection. So none of the three edges, so this edge or this edge or this edge, they are parallel, none of them are parallel to the screen. So because of this, the outline edges are inclined to the projection plane, therefore the edges do not show the true length. So this process is called as foreshortening. So if you say take this cube, say I am naming this as point A, this is my point B, this is my point C. So here if I connect these two diagonals, so these diagonally, and if I draw a perpendicular from point B, so this will intersect at, let us say, point D. So which means that if I having the cube like this, so first parallel, then incline, then another incline. So this will be isometric. So this edge, so if you connect this point to this point, this edge will be parallel to the screen. However, these outline edges, they will not be parallel. Only AC will be parallel. Therefore, AC will show the true length. Okay. So let us say that our AB is 1 unit. Okay. So AC means it is nothing but, according to this, you can say this will be 90 degree in the real, in the orientation it won't be 90 degree, but in the real time this AB and BC will be 90 degree to each other. Therefore, if you take the Pythagoras theorem, according to that, AC will be root 2. So this AD is nothing but half of AC, because this is a bisector. So half of root 2 will become 1 by root 2. So this AD becomes 1 by root 2. And now I am going to find what is AB. So AB real unit is 1 mm. But what is the foreshortened? See, as we told that only AC is the true length. Face diagonal AC shows the true length. So true length is root 2. Therefore, the projection length of AC is also equal to root 2. AC projection is also root 2. So you have to differentiate. Here AB equal to 1 unit. This is the true length. So we are assuming that this will be, suppose in this cube, if I am placing like this, so this will be 1 unit means. Now if I rotate like this and set the isometric projection, so this will be 1 unit in reality, but when it is projected onto the screen, it will be less than 1 mm. So what is that projection length only we are going to find. Since AC is a true gives a true length, therefore AC the true length of AC will be the same as the projection length of AC. So whatever we are drawing here will be is equal to root 2, and AD will be half of that, so it is 1 by root 2. Now this is a 90 degree triangle, and we can say that this will be 30 degree. So why this is 30 degree? This is because if we draw a line like this, so this will be 30 degree, because this will be 90 and total is 120, therefore this is 30. So this same thing, these lines and these lines are parallel, and this line and this line are parallel, so the same 30 degree goes into here. So if I have AD, then I can easily calculate AB, which is nothing but, this will be AD. This will be AD divided by cos of this angle, cos BAD. So 1 by root 2 divided by cos 30. So this will be equal to root 2 by root 3. That this will give us 0.816. So in reality, if AB is equal to 1 unit in the true length, so this is true. So what we will be drawing on the sheet will be 0.816. Okay. So again we have to differentiate what is the difference between the true length and what is the projected length, because as I told, the foreshortening process occurs, but this AC alone gives us the true length because it will be parallel to the screen. So because of that, this will be root 2 and this will be half of that, and by trigonometry we are finding what is the AB. So this is 0.816. So which means that if I have any suppose I am having a rectangle like this, so it is true in true length, it is, this will be 5, let us say, and this will be 3. So when I am drawing the isometric projection, so let us say that, so this is my x axis, so this will be my y axis, and this will be my z axis. So as I told here, so it will be like this. So I forgot to mention here, you can see this will be x, this will be y, and this, if I extend above, this will be z. But here in this case, if you see, it is slightly different. Here this is x, this is y, and this will be z. So like this. So you can use both. Here we are seeing the bottom surface, here we are seeing top surface, but generally we prefer the first configuration. So this is the first configuration, this is the second configuration. So it's nothing but in the first configuration we are seeing the top surface, in second configuration we are seeing the bottom surface of cube. So let us say that I am using first configuration and I am viewing the rectangle like this. So x and z will be my thing. So when I am marking, so let us say that I am using some other color. So when I am drawing the rectangle, so I draw like this. So this will be 30 degree. So when I am representing here this, so I will mark the points here, A, B, C, D. So true length of AB is 5, but the isometric length will be 5 into 0.816. So this will be somewhat, I think it will be around slightly more than 4 mm, but it will be less than 5 mm. Similarly, if I say BC will be, this will be 3 times 0.816. Because all the edges, as I told, they are foreshortened by this amount, so 0.816. So while we are drawing the isometric, we have to draw 5 in the 4 shortened lengths. But for sometimes, for the sake of convenience, we draw the isometric projection in true length itself. But generally, when we are asking, we have to draw it in the 4 shortened length. So this is the thing. Okay. So there is one thing called as coded plan. So this thing, rectangle, any doubt is there on how to draw the isometric view of the simple rectangle I showed you? So while we are drawing like this, another thing is we can draw in ZY plane also, or we can draw in XY plane also. So later we will see how these 3 things are different. So you can see for plane objects you can choose any of the 3, any 2 of the 3 axes for drawing. So any doubts till now? So why the foreshortening occurs? Okay, so if it is yes. Okay, so I will proceed. So for simple objects there is something called as coded plan. So coded plan is nothing but a tool to visualize and sketch isometric views from 2-dimensional code. So something like this. So I have 4 squares are there. Inside each square I am writing some number. So first of all, it means that there is, I am looking from the top. So plan means top. So when I am looking from the top, there is a 1 cube is here. So it is like your Lego toys where we are building cube upon cube. So here there is 1 cube. Here there is 2 cubes, one on top of each other. Here there are 3 cubes, one on top of the below one, and similarly there is 1 cube here. So for example, so this is my plan means in iso projection. So let in this case I am assuming this is my x and this is my y, and viewing is like this, front and top. So from top, if I see this 2 3 1 1 means I will write as 1 2 3 1. So 1 2 3 1. So if this is A, this is B, this is C, this is D. So this will be my A, my B, C and D. Okay. So I have drawn this square in the isometric and I have represented the code plan. So next what I should do is I have to create the object with block. So here there is 1 cube is there, here there is 2 cube is there, here there will be 1 2 and below there will be another cube, but it will not be hidden. So we are drawing 2 plus 1 3 and again this will be 1. So this is 1, this is 2, this is 3, this is 1. So after this, after erasing the things, so for example this edge will be redundant. After reducing the redundant edges, so I get this isometric. So edges where the 2 surfaces are intersecting, so this surface and this surface are intersecting this edge, so that edge alone are retained, other edges I am removing. So this is the final isometric sketch. So like this we can try some problem. So same code, there are 4 possibilities. So I am last time I looked from this direction. So this was the direction in which I looked. Is it true, or I looked at some other direction? Yes, I looked from this direction, so that this one will come first and this 2 will come to my left and this 1 will come to my right and the 3 will be behind. So this is this direction. So in this case we can say that we looked through x direction. So suppose if I am looking through the y direction, let us say, so first I will be able to see 2 blocks. So first I am going to draw 2 blocks, one on top of each other. This is my first block, this is my second block. So 2 blocks I have drawn here. So to my left there will be 3 blocks. again top. I have drawn 3 blocks, then 2 blocks. So to my right there will be 1 block. So let us say I am going to remove the hidden edges. This I will remove, this I will remove, this I will remove. Then I will slightly rejoin this. So this will be the orientation. So let us see. So as you see, this we are able to get it. So here there is 3, here there is 2, and here there is 1. So similarly I have drawn 1 here, I have drawn 2 here, I have drawn 3. So this is the W. So X we already saw. So let us now try some other direction. So now we can try Y. So I will erase this. So any doubt in this how I drew this thing, coded plan? So anybody has any doubt? Okay, if still there is any doubt, I will try for Y now, and you can follow that and you can see how it is done. So first is, I am going to draw 1. So since I am doing freehand, it will be slightly this thing. So again here 1. So here I am going to dot 3. This is the second cube, and now third cube. This is 3, and here there will be 1 cube, and on top of that I am drawing the second cube. Here is okay. I think we'll draw this thing. And I will erase this line. Okay, I think this is correct, I guess. Okay, so I think we have got the correctly. So similarly for Z, if you try, we can get like this. So here 3 here, then 1, then 2. The back side will be invisible. So any doubt in the coded plan? So I just illustrated how to draw a simple isometric object using coded plan. So is there any doubt in this? So I hope there is no doubt. Okay, so I will go to next one. So now simple polygons we are going to try. As I already illustrated the square or rectangle, again I will here mention. So So first for square means first we have to draw the orthographic view of the square or rectangle. So ABCD. So AB will be of some dimensions, BC will be of some dimensions. If it is square means all sides are equal. If it is rectangle means this will be one dimension and this will be another dimension. First we have to draw in the orthographic. So now we have to apply the foreshortening. So if this is say 5 units and this is say 6 units. So in the isometric, what AB length will be 5 into, so can anybody say what is that factor? So we just derived it. So it is nothing but 0.816. And BC in isometric will be, so this will also be AB and CD will be equal. So BC will be 6 into 0.816. So which means that, so this is be the value of BC and AD. So both will be same value. So now after getting these values, we have to draw the sides in the isometric view along the respective orientation of the axis. So as I told, there are 3 possible choices. So I mentioned here that I just drew about one case. So you can see in this rectangle I have drawn only one case, but I told you that you can select either X and Z, or you can select Y and Z, or you can select X and Y. So that only we are going to see now. So here, which means that this is my X, this will be my Y, this will be my Z. So in this I am going to draw in the XZ plane. So this will be 30 degree and AD will be 90 degree. So here if I see, this will be my imaginary X axis, this will be my Y axis, and this will be my Z axis. So here Z is again 90 degree and Y is at 30. So this we are viewing like this, this we are viewing like this. Here this will be my X axis, this will be my Y axis, and this will be my imaginary Z axis. Okay. I'll draw a little straighter. Z axis. So here this will be 30 degree and this will also be 30 degree, and we are viewing this from the top to get the orthographic. So if I am drawing this isometric projection and we want to get the orthographic projection from that, means which direction to view, that is I am indicating. So isometric is only one view, but if you want to get the orthographic, which means if I indicate this, then I am getting this square. So here if I view this direction, I am getting the square. Similarly for this, if I am viewing from the top, I am getting the orthographic square. So while drawing ABCD, AB should be that 5 into 0.816, that you have to draw it along the 30 degree. So you have to set the, suppose if you have a drafter or a set square, you have to set it at 30 degree and first draw the value of CD, which is 5 into 0.816, and top you have to set at 90 degree and draw this 6 into 0.816. Again you have to set at 30 degree, draw the value of AB, and again set at 90 degree, draw the value of AD. So you can do two things. One, you can draw the isometric view according to the foreshortened length. Otherwise, if it is taking too much of confusion, means if you want to every time calculate, we can also draw the isometric view in the true length also. But it is better to draw it in the foreshortened length so that you are aware of what is the exact dimensioning. Because as I told you, the edges are not parallel to the viewing plane. So that is the thing. So because of that, we are drawing like this. So this was a square or rectangle. So triangle means so in this case, suppose if it's a equilateral triangle, So we can say that all angles are 60 degree, and all sides are equal. But this is only the case if the triangle is projected in the plane which is parallel. But in isometric, this projection is not parallel because the triangle is not parallel to the projection plane. So because of that, you will see that you are getting different values, and these angles will not be 60 degree. So this will be some other degree. So again, first we have to enclose this triangle inside a rectangle. So why we are doing is, we saw how to draw this rectangle. So we are going to apply that same principle. We are going to first draw this rectangle. So let us say this is my reference line. Here I am going to draw 30 degree and set the drafter 30 degree, draw BC, then 90 degree CD, then DE, then AB, EB. So after drawing the square, now what I am going to do is, so I am going to measure the value of EA. Suppose this is ED is equal to X, so EA will be X by 2. So because since it is a equilateral triangle, and you can say that this A will be at the midpoint of ED. So at the midpoint I am going to locate the point A. After locating that point A, I am going to draw two lines connecting one to B and another to C. So this is how we are going to draw the triangle. So we cannot directly measure the values of AB and then draw, because we don't know at what angle it is inclined. Because isometric, as we just saw, for the case of rectangle it is fine, we know the angles, but for the triangles we don't know what angle this will be. This will not be 60 degree, because if this is 30, then this total angle should be 60 degree, because EB is vertical and this will be horizontal, so this will be 60. So you can see that this angle which I am representing to this triple arc, it will be something less than 60 degree. So we don't know at what angle it is located. So because of that, what we are doing is, first we are locating the point A. Here it was simple because A is located at midpoint of ED. So whatever the projected value of ED, so ED will be, so if it is X in the orthographic, it will be X into 0.816 in the isometric, and here we are locating the midpoint. After locating the midpoint, we are drawing two lines to connect to B and C, and our triangle is ready. So this is for the second orientation. So this was, let us say this is X, this is Z. So in this case this will be Z and this will be Y. Here it will be X and Y. So any doubt in triangle? So how to draw isometric view of triangle? So this is the case. So if this was not equilateral triangle, then let us say this triangle was something like this. So how to do? That time, suppose let us say this is A dash. So we have to measure what is EA dash. So let us say that EA dash is some value. So let us say it is value of T. So we have to calculate EA dash in isometric. So ISO will be equal to 0.816 into T. So again I am telling you, if you are following this foreshortening means, then you have to do these things. Otherwise, if you are not following the foreshortening, then you can avoid this 0.816. So if you are drawing the value of ED as the true length itself, then EA also you can locate it. So let us say after calculating this, I am locating the point A dash at here. So then I will take new color. I can connect the triangle like this. So that will give my isometric. So this is triangle is concerned. So next is pentagon. So pentagon, as we know, in the orthographic, when we are seeing the true shape, all the angles will be 108 degree. So all the angles will be 108 degree, and all the sides will be equal. But in the isometric, this 108 will change. So how to overcome means, again similarly for triangle we have to close this inside a rectangle. So this length of BE and this vertical length, so whatever this vertical length and whatever is this BE, so for that we are drawing a outer rectangle, and first we are drawing the isometric view of the rectangle, and after that we have to measure what is this point A distance from 1, what is the point B distance from 1. So we, after measuring all the distances, we have to convert it into the four shortened values, and then mark the point. This will be point A, this will be point B. So point C will be at a distance of something from point 2, then point D and point T. So like this you have to mark after measuring each length. So this is will be X means. So you have to measure here and you have to mark it. So this will be, if you are not sure foreshortening, it will be X. If you are foreshortening, it will be 0.816 into X. Similarly, this point B you can locate from 1, the point E you can locate from 4 or 3, and point C you can either locate from 2, and point D you can locate from 3. So like that we are drawing this pentagon. So again there are 3 orientations. So now circle. So till now we saw regular object, so now regular polygon, so now we are seeing the circle. So there are 2 methods for drawing the isometric view of circle. One is the method of points, and another is the 4 center method. So first, with center as O, we have to draw a circle, and then again similarly for this pentagon we are enclosing it inside this in square. So here it will not be rectangle, it will be a square, because this DC will be equal to diameter of the circle. Same way this BC will also be equal to diameter of the circle. So with the diameter of the circle we are drawing the square with the side length, and now we are drawing the 2 diagonals. Okay, so first we are marking the midpoints as 1, 2, 3 and 4. So this will where the circle will be tangential and it will touch the side. So that first we are marking midpoint, then we are drawing the 2 diagonals, and then we are marking this point as 0.5, this as 0.6, this as 0.7, this as 0.8, and with 5, 6, 7, 8 we are drawing another square inside, and for that we are marking the midpoints as P, Q, R and S. So first we have to, if you are following closely, first we draw this circle. Okay, first we are drawing the circle. So if I want to reproduce, then I am drawing the square around it. Okay, and I am drawing these 2 things. I am marking the midpoints. 1, let us take another color. 1, 2, 3, 4. Now what I am going to do is, I am going to mark the diagonals of the square like this. Okay, and now this another square will be generated, so that is the inner square. If I connect like this, I connect like this, connect like this, and connect like this, so I will get another square. So that points I am marking as 5, 6, 7 and 8. So this is the method of points, which means that I have now generated 8 points which are on the circle, and these 8 points I am going to draw in the isometric view, and I am going to draw a smooth curve that connects these 8 points. So how I am going to do that means, so if this is the center O, and this is P, this is Q, this is R, this is S. So you can refer this diagram for clarity. So how I am marking the points. So first I am drawing, as I repeat, drawing the circle, drawing the outer square, marking the midpoints 1, 2, 3 and 4, then connecting the diagonals, and those diagonals intersect the circle at 4 points. So it is 5, 6, 7 and 8, and now I am completing the square, which is 5, 6, 7, 8, and then I am marking the midpoints of this square. So this will be P, Q, R and S. So this is the sequence. Now what we are going to do is, now we are going to draw this square ABCD in the isometric, then mark the midpoints 1, 2, 3 and 4. So we have now got 4 points for the circle. So additionally we are going to measure what is this OP and what is this P5. So I am going to say OP in this direction and P5 in this direction. So I locate the point number 5. Similarly I do and locate the point number 6. So why we are doing this is this PR and this will be the horizontal. So whatever length along the horizontal, I am going to travel through this length only. So I cannot travel like this. So for example, I cannot measure O6 and mark it, because that is not possible. Since our axis is X and Z, I am only going to travel along the X and Z. So first I am measuring the OP, converting into foreshortened length and marking the point P, and then from there vertically I am measuring the P5, converting it into the foreshortened length and marking the point 5. So like this you can get 4 points, 0.5, 0.6, 0.7 and 0.8. And with 1, 2, 3, 4, 5, 6, 7, 8 you are going to draw a smooth curve like this. So it's freehand, so it is a little shaky, but as you got the idea, so I will again repeat it in this new here. So first draw the reference line, draw the square first, outer square, mark the midpoints, now from this point O along this direction measure the point P, and from here above measure 0.5. Similarly you can get 0.6, 0.7, 0.8. So connect all these points. So this 1, 2, 3, 4 and 5, 6, 7, 8. So how I got this means, first of all this will be along the diagonal. So how I am going is, I am measuring along this direction up to OP, and then vertically above I am measuring P5. So if I extend this line like this, if I extend this line, both will be parallel to each other. So along this direction I am measuring this OP, and along this direction I am measuring P5. Either you can take true or you can take the foreshortened length. So if you are following, you have to follow it uniformly. If you are going to foreshorten, then you have to foreshorten all the length. Otherwise you have to fully follow the true length. If you do mixing, then that will be wrong. So for example, this edge I am following the true length and this line I am following foreshorten, that is wrong. So for example, if it is true and if it is foreshortened, so that is wrong. If you foreshorten, you have to foreshorten everything equally, or you have to foreshorten, you have to totally avoid it. Okay, so like this I just explained how to draw the isometric view of circle using the method of points. So now we are coming is 4 center method. So again draw this circle, draw the square around it, mark the midpoints 1, 2, 3, 4. So now again, so after doing that, draw the reference line. This is the till this it is clear, and mark the midpoints. Okay, so now what you have to do is find out which is the shorter diagonal. So here you can see both AC and BD both will be equal only, actually, because in the true length square both the diagonals will be of equal length. But if you are drawing in the isometric projection, let us say I am using different color and I am drawing the dash line. This will be one diagonal, this will be another diagonal. So if this is A, this is B, this is C, this is D, my BD is the longer diagonal in this case and AC is a shorter diagonal. So AC is shorter diagonal. So after finding out the shorter diagonal, what we have to do is we have to draw 2 lines. From this C you have to connect the opposite midpoints. So as I told, there are 4 midpoints. This is point 1, point 2, 0.3, 0.4. Now you have to connect C to 4 and C to 1. Similarly, you have to connect A to 3 and A to 2. And remember, all this is we have to do it only for the this one. So we have to do this only for shorter diagonal. That is what I am meaning. So we should not do for longer diagonal. We should do for shorter diagonal. So we will get two intersection points. Okay. So first of all, before that, we have to draw two arcs. Okay, I will use this color. So with A as center and A3 as radius, we have to draw an arc which is connecting the 2 and 3. Similarly, with C as center and C4 as radius, draw an arc which will connect like this. Which will connect 4 and 1. Now with E as center, so if I forgot to mark these 2 points, this will be my, let us say this is my F and this is my E. So where these two lines are intersecting, that is E and that is F. So with E as center and E1 as radius, E1 and E2 will be equal. Draw one arc which will connect like this. Similarly with F as center and F3 as radius, draw an arc which will connect like this. So now we have drawn here. So here if I say this is my F means, so with this I draw this arc, and with E as center I am drawing this connecting 1 and 2. So here with C as center I connected 4 and 1. Here A as center I connected 2 and 3. So like this I am able to draw the this thing. So this will be more accurate than this freehand. This is a method of points and this is a 4 center method. So what were the 4 centers? One center is point A, through which we draw this arc. So this is arc 1. So with C as center we draw this arc which is arc 2. So this arc 1 and arc 2 are nothing but long arcs, and this is arc 3, this arc 4. These two are called shorter arcs, smaller arcs. So these 4 arcs combined together, they give us the isometric view of the circle. So this will look like a ellipse. So this is how we say the circular object. So after we saw the circle, polygons, and we saw the coded plan. Here rectangle, triangle, pentagon and circle. So now we are going to draw isometric from orthographic. Okay, so this is the thing. So can anybody tell what is the angle of projection which is being followed here? So by looking at this figure, can anybody say? Can anybody guess what is this angle? Hello? So this is my front view, this is my top view. So with this itself we can find. So if there is 2 figures means one will be front view and another is side view. Here there is one figure which means it is a top view. Top view is located below the front view means it is the first angle projection. So any doubt? So this is just a recap. So this first angle, this will be my right side view because I am drawing it towards the left side. So in first angle projection, right side view comes to the left of the front view. In third angle projection, right side view comes to the right of the front view. So I draw these three this thing. So now I want to draw the isometric. So how to do that? So first we have to mentally visualize how the object will be. So let us say that if my object was like this instead of this cut, so it will mean that my object is some kind of a box. So we'll try to draw that box first. So if I say so yes, so if I now try to connect like this, so which means that this is the material and here some material have been removed by slicing. So after slicing, what is the remaining that we are drawing? So this is the view. So in front view, this is the top view, and this will be the right side view. So in right side view, okay, so this is the visualization. So in front view, we will be able to see this rectangle. So this is the front view. In top view, you will be able to see the taper part. This will be the top view. In side view, you will able to be see two parts. One is this rectangle, which you will be able to see directly. Another this square, which will be inclined. So it will be this thing, shortened. So if I number, this is my surface 1. So in front view, this will be the surface 1. If I say this is surface 2, this should be corresponds to top view. If I say this is surface 3, so in side view you can say that this will be my surface 3 and this will be my surface 1. So that is how we are drawing. So how to draw isometric from orthographic? So first of all, we have to mentally visualize. So first we need to say that there is a box. So it is 20 mm and 30 mm. Okay. So first I draw this box. So let us say I am drawing 30 mm here and 20 mm here. Like this, and height is 5 mm. So I'll draw 5 mm. Sorry, I'll erase this. So in isometric, always you have to erase the hidden. So what all will be hidden? This will be hidden. This will be hidden. This will be hidden. So like this, you will be able to see the box. I'll slightly modify. So 30, 20 and 5. Okay. So like this. Okay. So this will be my front view, then this will be my top view, this will be my right side view. Okay, I will now do one thing. I will slightly reorient it differently. So let me say that I am seeing the front view from here. So this will be my 30 mm, this will be my 20 mm, this will be the height. Like this I am saying. So now right side will be visible. So now what we are going to do, we have drawn the box, but this is not the object. So here what we are going to do, we are going to mark the at 10 mm. So midpoint we are going to mark it, and from this we are going to draw two lines. This line, and this line. After drawing this, we have to erase the sliced portion, which will be this one, this one, this one, this one, and this one. Now draw the object like this. If you extend this, this will be 30 degree. If you extend this, this will also be 30 degree. So if I go into dimension means this will be 30. So here I am, for the sake of convenience, I am following the true length. In reality, when I am drawing, this will be 30 into 0.816. This will be my 20. This will be my 5, and this will be my 10. So how we did this? So for example, if I also represent the sliced portion like this. So what happened is, this was the cutout portion, so this will also be 30 degree. Okay, so as I have made a mistake, so this will not be 30, this will be less than 30 degree. Okay, so this will be 30. So why we first draw the box means, we know that the box will only be inclined along the isometric axis. So if this was my x-axis, this will be my y-axis. So you can see that this line is not along the y-axis, only this dotted line is along y-axis, which means that here this dotted line is along y-axis and this will be my z-axis. So after drawing the box only we can get an idea. So we mark the 10 mm and we drew the line and we cut out this part. So that is the this is a simple object. So here you can see, if I erase this, so I am erasing. After erasing, you can see that this is the final isometric view. So this will be the object. So here, if I draw the reference line, if I draw the reference line, this will be 30 and this will also be 30. However, this angle will not be 30. This will be some other angle, this will be some other angle. So it is less than, it will be, I think, less than 30, this one. Okay, so this is the thing. So next we are going to see this is a problem. So this is first angle projection, means my top will be the front view and the bottom will be top view. So if I want to mentally visualize this object, how it will be means, so I am seeing some kind of a step arrangement, and this step arrangement is only for up to some length. So this is 36 mm, means this will be 64. So for 64 mm I am able to see some step arrangement. After that it is some box arrangement. So this is the object. So I am seeing step arrangement and box. So first we are going to draw this big box. So that will be, so this will be 100 mm. This will be 48 mm. So like that we are going to draw. So the complete isometric I have shown here. First we are going to draw this. So if I indicate the reference line, this will be 30 degree and this will be 30 degree. So are you guys following what is being told? So we are seeing isometric of objects through orthographic. So here I am going to mark 48, I am going to mark 100, I am going to complete the box, and I am going to draw for this, sorry, this is not 48, this will be 25 plus 25, 25, this will be 75. Again, sorry for this mistake. So this will be 75 because this length, so this will be my front view length. So here you can see 25, 25, 25. So if I add everything, it is 75. So 75, then 100 mm, and this thickness, this height will be 48. So I am going to draw completely the box. Then what I am going to do, at a 25 mm distance, I am going to draw a full parallel line, and again this at 36 mm distance I am going to draw a parallel line. So these both will intersect at a point, so that will be this point, and so we have drawn this line and we have drawn this total line, and from there I am going to reduce one step. So this will be 16 mm because total is 48, this is 16, 16, so this will also be 16. Now I am going to come down 16 mm, here also I am going to come down 16 mm, and I am going to join this. Then again I am going to go 25 mm towards the so if this is x axis, this is y axis, and if the top is says this is z axis, along minus x I am going to come 25, and similarly from here along minus x I am going to come 25. Again I am going to join these 2 points. Again come down along minus z, I am going to come down 16 mm. I am going to come down 16 mm, join these 2 lines. Again going minus 25, and then join 2 lines. So like this we are going to get this object. So next object is first angle projection, which means that this is front view, this is top view. So here we are able to see something. If you again try to mentally visualize this, what it means, in front we are able to see some 2 triangles are there. In top view we are able to see some 4 triangles. So first of all you have to be mentally be able to visualize. So what I am able to see is that some L-shaped object is there, and from which some slicing has been done. So we are now cutting this L-shaped object along a inclined along an oblique plane. So because of that we are able to see something like this. So if I here the object, so this was my initially L-shaped. So this will be my base, like this L-shaped object, and from here instead of if I extrude this L-shaped object above, you will get some object. So in that you will be able to see this L shape as top view, and now I am slicing this object like this. So how I am sliced means, so I have sliced like this, and here also I have sliced like this. So in essentially what we are able to see here is, suppose let's say this is surface 1, this is surface 2, this is surface 3, this is surface 4. So if this is front view, in front view you will be able to see 1 and 3. In top you will be able to see all. So this will be 4, this will be 3, this will be 2, and this will be 1. So are you following what is being done here? Okay, I'll erase this. So if I carefully draw, this will be my base, and from this if I see, so okay, so here you can be able to visualize the isometric. So from this L-shaped object, so this L shape I am extruding for some height. So this height will be 50 mm. First we are drawing the L-shaped object. So let us say we are starting from this point. This will be 30 degree. This will also be 30 degree. First we draw this of 20 mm, go above 50 mm. Here this will be 45, which is 25 plus 20. This will be again same 45. This will be 50, same. This value will be this value 20. This value will be this value 25, and this will be 25. So now we completed the L-shaped object. So after completing this L-shaped object, which is this red color, what I am going to do this from this point, from this point, from this point, from this point and this point, all these 5 points, that is from, so 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5. I draw all lines which are going to connect this point. So let us say this is point O. So I am going to connect all these lines. So after that you can see that this is the isometric view. So finally this thick object with the black color is the isometric. So this L-shaped object I draw for the reference. because it will be easy. So we cannot directly draw these lines. After drawing this L shape object only, we are able to know from where we are going to connect it. So like this we are drawing it. So this is another object. So if you see here, you can say that this is some box on which there is an surface is there. So that surface, if you look from top view, it is sort of inclined in the front view, and the top view there is edges passing, and this some square cut is there in between, and this part is, you can see that it's a oblique surface. So it is inclined in all the three things. So how this will look like is like this. So first you have to draw this object, this lower box, and project it fully, draw it to the full length, and then again for top, what I am going to do is I am going to draw the enclosing rectangle, and here also I draw the enclosing rectangle, and I fully draw it, and up to the total length. So this length is 40 mm. So this length, so if I draw this, so this thing will be alone will be 30 mm. Then 30 mm, this top will again be 30 mm. So 30, 30, 40, I draw a box, and what I am going to do is, I don't know how to draw this inclined length. So in this I am going to mark this. So this will be 8 mm, and this will also be 8 mm. Same thing you can mark here, this will be 8 mm, this will be 8 mm. So these points we got. So which means that this point, this point, this point, and this point we have marked it. So now we have to mark this point, this point, this point, and this point. So how we are going to do? 10 mm we are going to travel like this. This will be 10 mm. So this was 8 mm. This will be 10 mm. So travel 10 mm, mark these 4 points, 1, 2, 3, 4. So from here also 10 mm, this will be 10. Again this will parallel 10. After going that, we are going to mark these 4 points. So these 4 points we marked it. And now if you see, there is some inclined surface is there. So after marking this point and this point, we have to connect these two lines. So here also at 15 mm, and from here 8 mm. So this point we got, this point we got. So we connect these two like this. Similarly we do here, similarly we do it here, and similarly this side it will be hidden. So we are not doing that. So how to get this line? So if I take yellow means how to get this line? That we have, again we know from here. So what is this value? So that is 10 mm as indicated over here, and this will be this small. So how we are going to calculate means, this is 30 mm, so this half will be 15 mm. So this is 25 means this half will be 12.5. So rest 2.5 mm gap is there. So this 15 minus 12. So if I take from this midpoint, I drop a line, and from this point to this point you can mark it. It will be 15 mm, and from this point to this point it will be 12.5 mm. So if I go 10 mm down and 12.5 mm like this way, I am able to get this point. So I am going to connect these two, and this length is 20 mm. I am going to draw 20 mm like this, and similarly I am going to go this way. Here also I can draw this line, and you can parallel to this line you can draw another this line. So here the inside part will be hidden. So this outline we got finally. And if you, so after solving this part, the second part is how we are going to do is, first we have to draw the box which is of the size 40. So this will be 50 minus 30, which will be 20, 20, 40, and this will be 15. 20, 40, 15, you are going to draw the box, and then from this point we are going to connect here and here and here, and we are going to slice the object. So these red lines will disappear, so this new outline will be like this. So in the 3D visualization, what we have done is, after drawing this part, we are slicing the object. You can see that the sliced portion we have seen. So if you see this from the top, you will be able to see something, this portion like this. Like this you will be able to see. If you see from the side, you will be able to see this portion like this. And in the front, if you only that box I am concentrating, you can see that it will be like this. So you can see that like this and like this. So this portion will be there and this portion will be there. So in top view it came like this. So this is this one, and in side view it came like this. So this is that thing. Okay, so last question. So with this is a feature with hole. So as usual, first this is the visualization. So how to draw this in ISO means, first we have to evaluate the total dimensions. So this is 30 plus 15 plus 50. This will be totally 60, and this will be 30 plus 38, which will be 68, and this one will be 30. 30 or 30 means this total will be 60, and this height is 18 mm. So by 60 by 68 by 18, first we are drawing a big box. So this red color outer will be that box, and then we are going 10 mm side and 18 mm down. We are going to cut that, and so that will be represented by this. And for the sake of arc, what we are going to do is, we follow the circle. So this is 30 mm. So we have to draw a box which is size like this, 60 mm. Follow the 4 center method, and you will get something like a full circle. You will get it. So that we are going to only consider first half, since it is a semicircle, and we retain that. And for this hole, what we are going to do is, we are going to draw this inner side of rhombus. So to locate that, first of all, from this midpoint we have to locate this midpoint at 30 mm, and from this side again it will be 30 mm. So at that point we locate the midpoint, and then we draw a square. In the isometric it will be like a rhombus. So this will be of side 30, 30, 30, 30, and we mark the midpoints 1, 2, 3 and 4. After marking the midpoints, we notice that this is the shorter diagonal. So this is the shorter diagonal. So from the shorter diagonal we are going to connect this way and this way, and from the other end of the shorter diagonal we are going to connect to the opposite midpoints, this way and this way. Using the 4 center method, we are going to draw these 4 arcs. So that is how we get this circle. Same circle, we have to same setup, this entire square, all these things we have to now move down by 18 mm, and we are going to draw another arc. So but what will happen is, only this portion will be visible inside the hole, which is corresponds to this portion. So rest of the thing will be hidden. After drawing this arc, and again the same thing for this upper arc, again we have to repeat the same 4 center method, get the bottom one, and you will able to draw an arc which will be parallel, but it will be something like this. So something like this it will come. So after this and this arc and this arc, top arc, we draw a tangential line that will connect this. So that is what this tangential line. So this is how we draw a feature with a hole. So with this we end this session. So any doubts in what we discussed? So does anybody have any doubt? Hello. So is it clear? So what we all discussed, isometric. So you can take in meanwhile some there are a lot of example problems in ND, but you can just visualize the orthographic, and then you have to come up with the mental idea how it will look in the ISO, and then you have to develop the ISO sketch. So any doubts we have in what we discussed? So just a small recap of what we did. So we introduced the isometric projection. So before that we did a recap of the projection methods, introduced the isometric projection. So foreshortening we saw. Then first we saw what is coded plan and how to generate isometric from that. Second is we saw some simple shapes. First is rectangle, square, then triangle, then pentagon, then circle. Circle two methods we saw. One is method of points, another is core center method. So then from the orthographic view, how we are going to generate the isometric view, that we saw. So first the simple taper object, then this stepped object, then this sliced object which is oblique, and then we saw this 3D object. So this is so you have to first strategize how we are going to draw the object. So part by part we did, and next we saw this feature with hole. So any doubts in what we discussed till now? So if there are no doubts, can we log off the session? Okay, so okay, if there are no doubts. Okay, sir, no doubts, right? Okay, I am not able to hear. Selvaraju is talking. So can you message? So I'm not able to hear what you are telling. So can you put us a message? So if it is okay, then we can stop the session. So okay, you are clear. Thank you. Okay. Think there is a issue. So okay. So shall we stop this? Okay, I will stop the recording now.